Okay, today we have 2 topics. Actually, now we have 5 classes, as I explained it before, and we need to cover several topics. So, on this class, we are covering inertial and non-inertial systems. On the next class, it will be a theorem of center of mass, center of the system of it's fancy word, it's a big theorem. It will be next class. After this, we will start to cover topics about inertial momentum or inertia. Don't deal with mass. Okay.
What about the Ampere principle?
It will be you won't cover. We won't cover it.
Actually, we already covered it.
I mean, we won't solve task using yes covered.
So will this be in the exam?
Not of course.
Why?
You have on exams only my material.
Interesting concept.
You didn't get that he explained you some fancy high cloud stuff and
So these lectures and tutorials.
yeah, let's call it like I don't know.
Termech talks.
Okay. Yes. Okay. So the first the only one question was, except your question about Pixie camera.
Yeah.
Actually, I didn't find it yet.
What?
So I didn't find it. Okay, so it's about slide from previous class or from previous semester. I mean, from previous year.
Which one? The question?
Yeah, the question is about slide from previous year. So the answer is following that. Actually, I get that our lectures it's not really related to your grade.
It was the same also last year?
Not the last year it was precisely the lesson the lab was how to say was the same topic.
Coherent.
Yes, it's correlated to each other. So I'll send it to you, but before this I put most of the needed material. I'll put it on slide. So now we have also some kind of lecture-like labs because I have to provide some material which you haven't had during the lecture. So our first, sorry, I didn't prepare the, kind of solution, but I will do it till on Thursday. I will do it. So now, yes. Also, thanks to you that for the next year starts now, and it will be also for the fourth year. I mean, for the next years that. It's big home task, so I provided it on Wednesday. On still Thursday, you should provide it to me.
Next Thursday.
Next Thursday, yes. I mean, 1 week, 1 full week.
Yeah,
Wednesday till Wednesday, but Wednesday even this day. I mean, so I think it's fair.
Yeah.
And it's better than till Sunday and so on. So thanks to you because now I know. I mean, know how to handle it. It will be our task. So we have a board. We know the velocity of it, mass, resistance force, and we need to find the equation of motion of this boat and the time with the boat speed will be reduced wisely. So there are 2 questions which you may ask. What does it mean, resistance force? And also, how can we do it? So for to answer on this question, first of all, we need to go about algorithm. You may read, and I need to prepare my cheat sheet. So actually, we just how to say on statics we started to do it. Now we just need to how to say enhance our algorithm. We will do it step by step using this algorithm, but for now, I need to give you some material, like lecture, as I told you before. So, about this. First of all, yes, analyze system, show the frame, as we did it on statics. Show a particle in common position, I will explain what is it and what the difference between previous stuff. After this, you need to analyze forces and solve the problem. So, different equation, find a common solution, substitute, and blah, blah, blah. Actually, nothing special. You just need to go step by step. Okay, so during our course, we have different types or kind, probably should be types of forces. So it can be constant forces, and depend of time, position, velocity, something combination of it, and also more fancy, like actually it's the same, but it was in vector form. It is in coordinate form. I mean, we split it on bases. Constant forces. Actually, it's our dear friend who likes apples and how to say, meat it with on here in. Yes, my English is potato today. Okay, it's related to the distance, but actually we won't use it now. But we just need to know that this force is related to, I mean, depends on distance. Also, we have resistant force. So it's submarine and it's missile. Missile. Missile.
Missile, torpedo.
Torpedo. Okay. So actually, you won't cover it at school and probably in results class. I mean, previous. So actually, when we are talking about resistant force, it's how the air or whatever resistance on your body. We cover it in two. When our, say, our not device, vehicle, whatever, moves slowly, relatively slowly, of course, but slow. In this case, it's related to just velocity, and this is the equation. If we are talking about the torpedo missile, it will be velocity square, and it has different equation. You may see it depends on vector too. I mean, its amplitude, magnitude, and its vector. If we are talking about underwater robots, in this case, it will be even more difficult. It's even more nonlinear than that's now. We have controlled forces. Mainly, it's about robots because we can control their torques, their accelerations, and so on. So it depends on it. We will meet it soon when we will talking about Lagrangian equations, because actually in Lagrange, the common task will be also a manipulator, and we will cover this one. Now let's go about kind of differential equations. Actually, when we are talking about solution in dynamics, we have two big steps. Actually, about grading, I didn't say it yet, but probably the first part will be graded more than the second one. The first part, it's force analysis, so you need to obtain equations. I mean, so like this, for instance, mx 2 dot equal to f. So you solve, we can say, more than half of the task, because it's creative part. I mean, because you need to think. The second part is to find integral, because you need to integrate. For instance, the task was to find the equation of motion. So we need to twice integrate this guy. It's also not easy, even if I talk about MATLAB and so on, the problem is that most of the time you need to provide me an equation of motion. So not just, you don't need to solve it numerically, you need to solve it analytically. Yes, you can do it in Wolfram, in MATLAB, but also you need to know how to do it by hands. Yes. To be honest, I also need to spend, I think, in Thursday, Friday, I need to refresh it in my mind because I also not so good in integrating. It's okay, because today we won't cover it, and you will have home task, actually during your home task, you can refresh also this knowledge. But you also can use laptop, just computer to find this solution. So, for instance, if we have rectilinear motion, just move, and we have constant f, the commonest task during your education. Meow, meow, meow. Common task.
The most.
So in this case, it moves along this side, so acceleration will be there, mx 2 dot f. We start to take integral the second time and receive 2 let me say, the initial conditions. Of course, to solve the real task, we need to put initial and other conditions. This is with respect to t, so it depends on time. In this case, it looks more difficult. Actually, this exponential form, I got it. I taught you this form during the linear algebra. Actually, we using matrices we received this form, if I'm not mistaken. Actually, you can. It should be also in discrete math, but you can open.
In differential
Right,
equations.
yeah. But actually, we also cover this topic in the linear algebra. Now we're talking about resistant force. Again, we have only one axis movement. If it depends on velocity, actually it's now our task will be soon. I showed it to you. We receive this one. After this, we need to take integral, and we receive this result. If we are talking about, if we have only one axis, actually it don't depend on anything. Actually, just square that's it. It will be your cheat sheet actually, because when we solve most of the tasks, it might help you. It's more advanced. So now our point move curvilinear. In this case, you may see you receive this shit stuff. And of course, it's much more difficult to integrate, and you need to use a computer for this. Yes, you can do it by yourself, but it seems. Also, it can be depends on position, and there are several solutions. It depends on. Actually, we won't have it today, so you can read it at home. If you have questions, you may ask me on Wednesday, or you can ask Kirill. I think in this he can explain it. And position and velocity depends. So again, position, velocity, boom, boom, boom. Use a super technique, and solution is following. Let's go to this task again. Any questions regarding the previous slide? Okay. So, first of all, what's the difference between explanatory image, in Russian пояснительный рисунок, and the scheme? Because if you draw me, so you have a task and you draw me, okay guys, so we have a board, we have a vine there, I don't know why. Also, it's quite important to have some trees. We also need to draw waves. It's not the scheme which you can use. You need to redraw it. Yes, you can use it to understand what's going on because it's really helpful. But when they talk about scheme, we need to redraw it using, for instance, actually this picture is not quite good enough for us. I'll explain why. So first of all, what?
Water also has some friction between those particles that we should consider.
First of all, so we need to write research object. What the research object is there?
The board. Absolutely rigid board.
What do you think?
We have both. We have water, and like the fluid, the water, and the
do we need to consider this as an absolute rigid body?
We can consider that as particle.
Why?
for simplicity.
The size of this body does not influence its Actually, it is. We can,
You can neglect. You
it.
can neglect it. Yes. So see, in this task, headshot. Okay.
Is recorded, you can go to the dean and tell him. Work like magic.
Okay, so actually we can think even so for the on the next class we have to cover it not as a particle but something else. Do we need to consider there that we have a person? Actually, it's not just a ball. Probably the person should be there.
It depends on the
Oh, it's
description of the task.
independent body.
Yes, I'm just. Yes, it sounds like philosophical question, but now I'm trying to explain you that it depends what are you try to find. The same with yo-yo. Because in yo-yo you can consider it even as a cylinder, but in some case probably you decide, okay, let's not consider this cylinder, but two cylinders, or even this complicated, complicated mechanism. So object research, research object is particle, it's ball. After this, we need to get what's going on. The motion. Why do we need it? Actually, it depends on the motion. You can provide the algorithm. Because if you know what kind of motion do you have, in this case, you can write the algorithm, and you need to write it explicitly. So, our motion, rectilinear, okay, it means that we can use the second Newton's law, actually. Because we have only one body, you need to write it. So,
Actually, it's not a condition. If I'm not mistaken.
I explain why. We use second.
No, it's important because you will ask us to write it on the exam, for example.
Not only for exam, actually, as I told you, it's if you open some papers, they also you should explain what.
Yes, but you can, like, condition of applying second Newton's law, it's not that motion. You need to have inertial coordinates.
Yes, and I didn't say why it's inertial coordinate system there. But we have one body, so and we don't need to say anything. So it's the reason why we can use second Newton law, because next my task will be non-inertial system, where we need to cover.
And probably we should
So
write
second
it
Newton law.
appropriately.
Okay. So after this, you need to write conditions. You can either draw the picture or write conditions. Actually, you can do it parallelly. It's up to you. So first of all, we need to draw some pictures. So we have point we need to put coordinate system. And we can draw. Actually, we don't need forces now. So, and it's in starting position, and for instance, in some position also. It should be there, for instance. For instance, we have a second task when the time board will be reduced wisely. For instance, probably it's there. Let's call it point B, point A, point 0, point A. Okay, initial conditions. In initial condition, we need to write. How many variables do you think we need to write there? It will be t. It will be x and x dot. So you have initial condition and some other conditions which we need to solve the task. In this case, what about t? What do we need to write there? Okay, can we do some, can we put something else? Can we put 1 million year before the crisis rise?
Yes.
Yes, we can. But for simplicity, to solve this task, it's better for us to use 0. But you need to keep in mind that you can put everything there. What about x? It's also equal to 0. I think you agree. This one, we know it. Okay. So now let's think about the second condition. Okay. We don't know t, so t we don't know. X we don't know either. About x dot, we know that it should be divided by 2.
This is constrained from the task, right?
Yeah. So find the time when the both speed will be reduced twice.
Why are we putting it under initial conditions?
It's not initial, I just. It's our conditions. It's initial conditions.
How should we call this call? Like second one, not initial one.
Actually, we just wrote conditions and put 0 there as the initial.
Okay. How we should
Call the call after this.
Up to you can know. You can
Not
just
initial condition.
Final conditions.
final yes, you can call
It
final.
does not necessarily have to be final.
Actually, in Russian, it's just конечный yes. So final. In Russian, it's called final conditions, but you can write whatever. I mean, you can just call these topic conditions, and that's it. Okay.
Yes, fast as possible.
After this, we need to make. This is possible. Okay. After this, we need to start to make a force analysis. For this task, actually, we don't need to change our. So the force will be there, and they're the same. Actually, we don't need to draw several pictures there. It's not necessary. But in some cases, it's necessary.
You defined your coordinate system like this, but both seem to be in point B, then time is equal to 0. So your initial
No,
condition,
he moved coordinate system.
but he didn't draw the coordinate system.
Like what?
He
I
wants
mean,
that.
point O is point B, like on the picture, the first one.
I told you for this task, actually for this task, you don't need to draw several pictures. But we are talking about, for instance, about
Just asking how did you define the initial condition?
initial
Like
condition.
on the picture, on this picture, x0 is not 0.
Yes.
It's b.
But he moved to B. And then he...
But he didn't draw this. He drew it like this.
No, wait.
I decided this picture
XY,
is
XY.
it's explanatory image. It's not a scheme for us.
Oh.
They have 0 there, but it's a choice. My choice to put it in 0. Okay,
Where is your plot now? In point A?
And 0?
0. Yes.
But
It's
It moves.
imaginary picture.
Maybe.
In not imaginary, I mean explanatory picture. Okay, guys, we spent our time.
For the task.
So
Oh.
we have mg. Of course, it should be our bot not sunken. I mean sinking. Sinking. So we have Archimedes force. Also, and we have some force. Straight force. Okay. After this, we need to write forces explicitly because we need to get what we have and how we can rewrite it. So,
Like, in order not to make this mess, can we define coordinate system like to the on the left side or something?
yes, you can after this just write 0 there.
yeah, actually, final conditions x equal b, or otherwise you will not be able to find it.
No,
So you need to know point.
So we know this
it's
one.
not given. It's not given.
Yes, no mg, and that's it. and we have a function.
It's force analysis.
What?
Force analysis technique.
Yes, it's force analysis, yes. I wrote all forces which we have. What's my next step? I need to, okay, I wrote second Newton law. Let's go. We need to write it in both ways, in x and y direction. But first we can just write MA is F minus plus MG plus FC. Now we need to rewrite it in x and y direction. Actually, I hope you get that we don't need y direction there, because it won't help us to solve the task. We need only x direction. But if you can, it's better to write, because in this case you can check that, okay, I didn't miss something. Because in this case, firstly, when I solved at home, I forgot that we have Archimedes force. Because, when Maleta saw it, okay, like your boat just now on the bottom of the sea. Okay, good like it. So, I started to write it in x. M x2 dot equal to minus k. We know this k because it was given, of course. Otherwise, you cannot solve this task. It's our system. Let me say, hooray! So the one of the half of the task is done. After this, we need to integrate it because we need to find the equation of motion. In this case, I use my cheat sheet. It is. And I can write that actually we have k there instead of this guy. And we know C1. And okay. So now we can say that we found the equation of motion. But we need to put initial conditions. Do you remember how to do it?
Yes.
So how? We have C1, what is it, C1 and C2?
Yeah, plug them here in both equation and get C1, C2.
You can just put all the initial conditions you know and solve for C1, C2.
Okay, so we need to put it there. Yes, am I right?
Yes.
T there. And after this, you will receive C1. We put it and find. Okay. So now we found all initial conditions. What's the next step?
You have your function.
I have function. I solved first task.
You
How
have
to
your
solve the
function.
second task?
You have function of velocity. You plug your final velocity into this function and find the appropriate time, position, time in this case.
So what do I need to do? I know this one. I just need to put it there.
Yeah. And solve for t.
Yes. And we need to subtract, find t. Okay. I just checking that you remember something. Okay. Did you get any problems? Any suggestions, questions? And after this, as you remember, we need to with my equation of the motion and so on. Just highlight it and that's it. Of course, I will make a solution clear, in clear manner, but for now.
You didn't highlight it properly. You throw out the power.
Okay, degrade, like. You highlighted the wrong solution. Okay. Now we are going to the next task. By the way, I think we have time. Do you want to firstly take another task, or first of all you want to try our new knowledge, and after this we'll go to the next topic? I mean, this is the next task for you. I think let's, because we have time, let's first of all solve this task. After this, return to the non-inertial. I put it two tasks together because I thought that we won't have time, and in this case I need to give you material. If we have time, we can. Who wants to be on whiteboard?
That's why I'm good.
I thought it's a marker which helps you to work better. Take it. It's better.
Where is the blank one?
There is no, it's there.
Я по башке ты метко бросал.
Last day.
It was, how to say,
Slam dunk.
Piece of luck.
not piece of luck. It's the God's, how to say, God's hand.
Zeus.
They how to say.
Divine judgment.
I just delegate. They delegate me as a typical mortal to do some.
And by the way, Ahmed is not coming because like he's sick.
Again?
Yeah, it seems like he told me like high temperature and something.
Whoa, no corona here.
He told me like this happened last year also, like after every season, but like changing season between.
Oh, Russian season of flu.
Yeah.
Okay. Should it take as X this one? My rules.
My rules.
Yeah, exactly.
My body, my rules. So please see.
So you choose Y there and X there.
Right.
Okay. You're right, you know?
Also particle.
Yeah.
But you didn't find the pixel.
Yes. I will find it soon.
Yeah, please.
And my Raspberry Pi.
Your Raspberry Pi is already.
There are a lot of things. Like there is 4 hours.
Do you need Raspberry Pi? Just 3,000 rubles.
300,000 rubles. Well, no, I will change 300,000 rubles.
After this you can give, I'll say. Oh, I will steal
Rest
it.
in peace.
No, I can steal it from you after this during the night because we don't have
We have room blocked.
Yes, seriously.
Yeah.
Of these typical Egyptians.
No, we have 17 members, so we are locking the room.
What do you mean 17 member?
17. 7 or 6 in each sub team. We have 3 sub teams.
You're talking about sub teams. I thought
We
about
have
room.
no. We have like in the number of the teams, like members 17.
I thought about room. I mean, when you're living room. That first of all, you will put this raspberry to your apartment. In this case, I just need to go in at night, like in India, just steal it.
Our room, the door is like closed with the key and so on. So it's better.
Okay.
So yeah, we need the fixed camp for the junior team.
Do you have a junior team too?
This is the last year they will be able to participate, and they have experience from like that level. So.
So as you may see on this task, the course related to time. Or not?
Oh shit, I'm sorry.
It's
thought
going,
it's-
yeah.
I thought it's
Most of the people thought that it's going up, yes, but even Malaletov too, because I showed the stats to him on okay, why it's going up?
Yeah.
Because we can.
Because it has some hidden motor, right?
No, because we have a small slave who, so we can neglect his.
What is your story with slaves? Neglect. We can neglect.
I forgot that now we cannot use words master and slave. We need to use secondary and primary. Yeah, that's a mistake.
Well, Tannenbaum or whose book is it? Not Tannenbaum, but computer
Like
architecture.
any connection protocol uses like how it's called.
Master and slave.
I2C.
Yes, I2C. On most in rows in robotics everywhere you can see master and slave, and it's okay. I don't know why there's a Black Lives Matter. You're not black, don't worry.
Don't worry, you don't.
You become whitish because you live about 3 years in Russia.
Oh my. This really would be like hilarious when I see this record again. It will be super interesting.
Do you know that sounds might disappear suddenly?
Ah.
Sometimes.
Oh, problems with mic, problems with mic.
I just need to open some, for instance, I forgot what's called.
Machine learning models that detects inappropriate words, huh? New startup.
I see. The best startup ever.
Что мы вообще делаем? Вот, написать. Courses.
What about the mass is neglect? The mass. MG.
The way.
Yeah.
It's P. You got them right. It's P.
It's P, okay.
P.
You need to put it in courses too.
Okay. Okay, provide beta alpha.
So from Y we can find N, and from we can find P. We need to find P from the Y.
Why we need to find P if P is MG?
Projection on y-axis. Cosine, pico cosine. Yeah.
And here we need to find an equation. I just don't know where we need to integrate actually. It's time dependent, maybe because of that. So like this.
But we have a solution for this, so we can check it afterwards. But now I think we need to open our cheat sheet with this guy.
So our differential equation is like this.
Just take through.
We need to integrate it 2 times.
But now we have one extra component, so we need to remember how to work it.
Okay.
Other question?
Почему равна
Альфа 30.
Anyway, this F is frictional force or just like arbitrary force?
It's crawling up force.
So,
It's crawl.
should we have friction force or like?
No,
No friction,
no
it says.
friction.
Perfectly.
Perfect.
It's
Yes.
some slave in the box which.
I told you yes. It's like from the game. I forgot. Metal Gear Solid.
Ah, now I see. Okay, so we have the equation, but we don't have any. Ah, okay. I see. We need initial condition. So let's assume them. Okay, t equals 0. X0 equals 0.
Oh, it's equal to.
Eh?
Do you have something?
I just assume it that here we have 0.
Not.
Velocity will be v. It's given, I guess. Открой task, please.
So it will be the solution for
V0, дай мне.
m.
Убери ты это свое. открой
This is
сам.
the reason.
А, 4.
No, you found it.
Okay, so have now the expression. You can find
Yes.
this.
4.
X. Okay. Z0 is 4 equal to. Какая там масса? Блин, ну какой таск?
2 kilograms. So the final equation. T respect to time, yes, as you mentioned.
So that's sin 0, 0, C1 equal to 4.
Mm.
X2, X is 0.
It look like y sine 3 multiplied 0. You see, because yes, it's 1. Yes, it's correct. I just checking the solution.
0. Here it should be. Сколько сейчас он было? Сколько там альфа? 40.
As I told you, I'm checking that you're solving it correctly.
Don't worry about it. Plus C2, so it's all cancel out, expect this. So C2 is minus, not minus, but 4 over 6. Good. And the final answer,
Yeah, C2 is correct.
X equal.
You're a genius. Perfect. Danny is better than you. Accept.
Что поделать?
Minus. This 2t squared plus 4t plus this one. It's ugly, but
Yeah, I see. This looks. Yes, we have to square. So camera. I'll say. Get the
Say
solution.
hello.
Yes. Let's check that camera works. Bam, it works. Fine. Nice. I will send you this picture.
Where is Kolpachok?
Take it. Kolpachok, yes.
Kolpachok. It's from Kolpak. But you never say Kolpak, you say Kolpachok.
Yes.
Sometimes you say Kolpak.
Kolpak, it's like big.
Yes, big
Big
Kolpachok.
Big Kolpachok is Kolpak.
Big Kolpachok, yes. Also Kolpak, it's your head.
Definition. Kolpak.
Macedonian putting up my word.
Oh shit. You fuck up all my efforts.
Actually, you wrote it very nice. I really appreciate your solution.
Oh,
Yeah.
Okay.
Yeah, ты проникся просто.
Actually, what's the difference between this task?
Настоящий мужчина никогда не умеет.
What's the difference between this task and the previous task? Because now, as you remember, we had Coriolis acceleration. Now we have Coriolis force. First of all, I'd like to help you to get how to get the equation, because actually it's also the, let me say, the second Newton law. It looks like this. But I want to derive it for you. So MA equal rotation forces. I think you agree with it. After this, we can write it. So it's divided into three parts. Relative, A relative plus A transport plus Coriolis. So we can write it in this manner. So relative equal forces plus F E, I mean E in Russian, plus E core plus F F. Is the reason why we have the different sign? As you remember that it has different signs instead of your acceleration. I mean, do you remember when we had the station picture? So acceleration is a different sign because of it. Because actually it should be minus there, but just it's convention that we can write this force, which is A core, but with minus. It's called like positive. It's inertia. How it will be in English? This one, how it's called? Inertia force, if not mistaken.
Minus MA is
Inertia force,
Yes.
yes. So it's inertia force. Why do we need it? We need to compensate our non-inertiality.
You just
Yes,
prove
I
it
know.
on the other side.
Yes, actually, most of the most of the theorems actually just let's play with Newton laws in this way or in this way. Yes, but it's yes, but actually it's different. It's called a different theorem. But actually, it's second Newton law, but we just took some part from it.
State of the art.
And as you may see, the motion of the ball assuming the initial, so most of the time we need to find the relative acceleration, the relative motion.
Oh.
There are plenty of tasks with such kind of mechanism. Actually, I even thought to make this as a real experimental mechanism, and probably I will do it next semester. So we already solved this task on kinematics. So pi by b rotates about z-axis. Let's call it z.
He will have oscillation, he's got eccentric curve.
45 degrees, so let's take x there. Okay, a small hairball placed in pipe, determine the motion of the ball, assuming the initial velocity is 0, initial distance between ball equals to a. Neglect friction. Actually, it's quite important there, because in this case the task will be completely different and more complicated. Just for you to know. Okay. We want to solve this task. What the? Yes, of course, we need to write research object. It will be one particle. Motion. What the motion is?
Complex.
Yeah, curvature. I mean, yes, complex motion.
Can you always just write complex motion?
Because every motion is a
Every motion is some set of complex motion.
Complex curvaline, blah blah blah.
Lines.
Hence, we need to also use. Actually, I forgot how it's called. Let's call it second Newton. Law for non-inertial systems. Okay. After this, force analysis. Initial conditions. Sorry. T x dot t equal to 0, x equal to a, x dot equal to 0. So we need to find equation of motion. So just we need to find the equation. Force analysis. So what about force analysis then? We have mass, mg. What else? What forces do we have? We have these two inertias.
Вот это задача запомнить все везде. Если она вращается, а ее за ниточку тянут, и она такая. Еще хер только как решать. Логики. You just assume this.
Did we forget something else?
You're writing Russian F, right?
It's not FAP,
It's mosquito.
it's this.
You mean
Pi.
pi?
Yes.
But why you write forces pi?
It's inertia. Inertia and force.
We denote inertial forces.
It's not F, this one. It's different F.
And we denote it like phi.
What?
It's Russian notation or
I probably yes, Russian notation.
probably.
Maladev showed me in this way previous year.
So what is the difference between the inertial force and non-inertial?
Actually, just
Magnetic.
in terms, it's not physical because it's not exist in terms of vectors. We cannot put it there. I mean, in terms of it's not physical.
How can we do projections?
You can do projections, but I mean, in terms of
It's not real.
it's not real.
Yeah. You can project non-real vector, but you can.
That's why we say that acceleration
It's
projections.
the difference. It's the reason why they had different letter because the force are real. It's because we have force. As you remember, force it's between two objects. I mean, it's interaction between between two objects.
Yes.
But this one, it's not interaction between two forces. It's the unit. I mean, unity. Not unity. I mean, unit. It's unit which help us to compensate non-inertiality of our system.
Pseudo force.
Pseudo. Okay, we can call pseudo force, but in this case it's maybe tricky because you remember pseudo have different, sometimes different meaning.
Quasi.
Probably, I don't know, maybe quasi. Actually, you just need to get that it's not real. I mean, you cannot say, okay, I can measure this force. You cannot measure. You cannot measure this inertia.
Measure it. Like MA transport. MA coordinate.
Okay,
I measure.
so we need to write equation. M a relative to what? To mg plus epsilon plus f. So what do we need to do the next?
Like, not project stuff.
So we can rewrite it in terms of x and y axis. But first of all, we need to get where is this. Well, I mean the directions for these forces.
We will cross product.
So what do we need to do?
Она же еще подниматься надо.
Oh, it's not bad. Actually, yes, you can put x
So
there.
yes, since the
yeah.
transport force is caused by centripetal acceleration.
Actually, for this task, it's better idea to put x like this.
It should be along.
Yes.
Probably.
It's better to do like this.
And yeah, since the transport acceleration is caused by rotation of the rod.
We know that it's constant angular velocity.
So it's only normal one. That's why it will be directed outwards, like along x in the positive direction.
Mm-hmm.
And as for Coriolis, we cross product
Coriolis acceleration is
inwards.
omega cross product.
No, we need only direction. So this one.
Direction will be always
Perpendicular to rod, but in which direction?
to plane of.
So we have the angular velocity like this,
Yeah, and
and the velocity is like this. So
Wait, velocity there.
but like
like this.
no, we have zero velocity, but after this it will be directed there. So like perpendicular to AB, directed to C.
Actually, do we need it?
Yeah.
Yeah, we need to project stuff.
Yeah, I agree.
Perpendicular to AB and directed to C.
But do we need Coriolis force if it's always directed to pipe wall? I mean, so it will just So we have constant acceleration, angular acceleration of this pipe, and Coriolis force will just create normal force with respect to pipe. No? Yes? Maybe?
Help
Actually, I
opponents.
didn't get you.
No?
Again, try again.
May I draw it?
Yeah.
So, as I understood, let's look at. Okay, we have this thing.
Oh, you're drawing. I
And-
need to prepare the solution.
Yeah, and am I right that if we look at our scheme this way, so this pipe parallel to us, then Coriolis acceleration will be directed like this. Yes.
Wait, like
In
which-
right-hand rule, remember?
Yeah,
Like-
I remember, but
first finger along the.
правило же есть.
Yep. But like again, which from which side are we seeing this?
So we have
Show
The ball. Where is the ball?
ball there.
Okay, and
show
where's
velocity.
Velocity, so we can maybe
Okay.
like
Okay.
and
And so rotate
in-
angular.
No, angular velocity of this shit.
Throw angular velocity, please.
So if
The
как
direction.
называется орбита?
Okay.
What is that?
Секунду. So it's like
We should so
Coriolis
ball won't
acceleration
go.
will be in
It
plane.
touch the surface.
It will be in plane. It
So-
won't go 3D.
no.
Right-hand rule.
Yeah. Okay. Сейчас.
See the picture.
Yeah.
Area.
What is
Coriolis?
Coriolis is what? Which one?
Or it's not here because it's perpendicular.
Точно. Сейчас,
Right-hand rule.
сорян.
It's a
Again, where's
Yeah,
Coriolis?
I remember right hand rule, but I just forgot about
Yeah,
angular
I mean,
velocity
they should
produced
compensate
by
that.
angular
Yeah, but in the
rotation.
same, I mean, like the same
Angular
collinear.
with just
The
rotation.
same-
So
No, like if your angular velocity is in plane or out of plane, you just put your hand on the plane and you see Coriolis acceleration cannot go 3D.
yeah, we discussed it in the previous
Yeah,
time.
yeah.
Yes, that everything goes into linears.
No, differentiate it twice.
So let's go to the. So we have mg, this one.
Wait, so transport force here like includes tangential acceleration, or after this, or they like considering the general case.
What do you mean?
So A with subscript E is a transport acceleration. Am I right?
Mm,
Or total. Or what they call a subscript T.
Actually,
Because it is either sum of forces or what? So yeah, it should be. Oh no. Oh. sorry.
so actually you can get it from this equation.
Yeah, but
M omega square. It's normal.
it's only but the direction is okay.
After this, you write this equation like this.
Wait. They project stuff, so
So they project it on x-axis. But their axis is this one, as we discussed. As I change it there.
yes. No, the x-axis is
Yes.
so, but it's in this direction, so it should not be normal acceleration only, because normal acceleration only directed along the road.
It's normal, yes. But actually normal is total in transport. We just rotate.
Yep, but why the direction is along common x-axis, not along our x-axis?
What?
Почему?
Did you forget that we solved this task? So if you watch top-down view, so our acceleration should be normal, only normal, because you don't fall equal to 0.
Indeed. So since it's only normal, it should be directed along the road. No?
Because cross product, we should the shortest path. It should be perpendicular.
What we talking about?
Why the direction of AE
AE, you mean?
normal acceleration?
Actually, if you open the previous, how to say, do you remember the task when we have
That's interesting.
this one, when we have a point moves along this,
Yeah,
and our end was there?
yeah. But this rotates like around the point where it's fixed.
Actually, it's exactly the same as exactly the same task.
It rotates not this, it rotates this.
Oh,
And then you, wait.
You still rotate like this, and your Coriolis perpendicular to a plane.
Anymore.
Yes, it's the reason why we don't need it there.
It's
Because
not in plane.
it's not in plane, it looks there. It's the reason why you saved me that I a bit confused it like this. Actually, it's the
But
same
you
task.
look from this, it's omega, it looks like it can be misinterpreted.
Okay, did you get Henning? What's going on?
It's rotating like this.
Yes, we did. We had the same task in I especially took it because we had the same task on the
Next time,
on Coriolis. When we covered the inertial system.
Axis.
Did you get the same task from the solution? Yeah, it rotates like this. Is the reason why we have Coriolis there? Yes, it moves like there. So we don't need it because we need to find the equation of motion on the point. Our point moves only along the x-axis. So is the reason why we have only 3. In this case, I just forgot about n. That we have it. Actually, the problem appears when we will have friction. In this case, we'll have a lot of interesting computations. After this, we need to put it there. So we have this guy. Start to integrate. We integrating it, blah blah blah. Put initial. Actually, is the reason why I told you this the first part you need to think. After this, you just need to know how to solve it. Nothing special.
To think or to know.
Okay. Nasi Pazankova told me that in some math faculties, when you have a very ugly and big integral, you just say you need to take it from this or to this. It's their meme, because either if you can you need to take it from MATLAB or whatever using numerical methods, or there are big tables, a lot of tables of the already computed integral. So you don't need to calculate by yourself. You just need to take it from this or to this.
No.
And the last task, we have time, yeah. Just to.
Wait, now how it does it rotate? So
Yes, again, the same, totally the same.
This is more obvious.
yeah, this is more of it
Because it's fixed here and then so this is bump.
So-
this stuff is
What?
Open-ended.
Yes, because it should fly away. The task relate to the tube in the moment when the body leaves the tube.
No. Find the position on the ground after it lands.
Okay, how can we solve this task?
Write a bunch of equations.
Ух ты. What's the main problem there? What's the difference between the task which I provided to you and this one?
First of all, we have 0 angle, so we don't have it.
Do we have friction force? neglect the friction. So it just no.
Your position, like it's time variant, you want to fix it. You don't have fixed coordinate system with respect to body you study.
You have Coriolis, right? You have,
It's again Coriolis.
Yeah.
and you have the centrifugal force.
Actually, why do you need Coriolis if it's in the tube?
Yeah.
Like, it will try to move out of the tube, but tubes,
No, but it will allow.
yeah, it will
But
not allow.
it will move like after it goes, it will move like this.
Yes.
No.
But we need to find
Wait.
Not like this, but like with a little.
Not like this, it's mine.
Don't worry, it will be on your quiz soon. The questions how it should move. Okay.
So we have Coriolis acceleration because of moving.
Because of moving, we have it. We cannot.
Neglected.
Yes,
But
we neglected it because we
actual
don't
to
need.
normal force.
Yes,
Like they will compensate each other.
actually, why do we? Actually, we have it. Why? You can think when you rotate something like this.
Yep.
Our body touch the ground. I mean,
The surface. Inside.
yes. Instead, now we are thinking that it's the same. But if we have like this,
So it is not neglected.
in some cases, so what if in previous task we neglected because we don't need it. We don't need to find this acceleration. I mean, in the real case, it won't be there. I think you agree with me. It's we are looking into tube. So where will be your ball? It won't be there. It will be somewhere else, there.
Right. It does not.
It's in this task it's precise, but in a real case it won't be precise, and it's how to say. And in this case you'll receive different n. Your n will be change respect to time, because when it starts to move it will be.
And you deal with y also in that case. Here,
And also so somewhat should how to say help you to tie the ground. I mean someone should. Some force should be exist to how to say put you in this direction. So in this case, the problem is that we need to find velocity, so we need to play a bit another story. So in previous time we just integrated 2 times. There we need to think a bit. Again, relative force. I mean relative acceleration. So we're integrating it, find relative, put C1, because we have x0, v0, we have it. And after this, we can just in this equation. Because you need to, so you have, so you find the equation of velocity, I mean velocity equation. After this, you just need to put L correctly, because it's your. The problem will be with velocity this time. Because you don't know velocity, so you actually need to find it. Okay. So for tomorrow, no home task as usual.
Yeah.
Because we have home task only on.
By the way,
We have exam tomorrow.